Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everybody. Okay, so for today's lesson, we are going to proceed with coordinate geometry under the subtopic equation of Loci. Okay, let's move on. Okay, our objective for today's lessons are, first, at the end of the class, you should be able to represent graphically the locus that satisfies these conditions, which are the distance of a moving point from a fixed point is constant, and the other one is the ratio of a moving point from two fixed points is constant, and hence determine the equation of the locus. The other one, at the end of the class, you should be able to solve problems involving equation of loci. Okay, what is it about locus? Okay, by the way, loci is the plural for locus. Okay, locus is the singular. Okay, what is it about locus? So you should know what is locus actually, because you have learned it during your lower form. Okay, so let's look at locus. So a locus is the set of all points usually forming a curve or surface satisfying some conditions. For example, the locus of points in the plane equidistant from a given point is a circle, and the set of points in tree space equidistant from a given point is a sphere. Okay, let's explore. Okay, our first activity. So our aim is to explore the shape and determine the equation of locus of a moving point which the distance from a fixed point is constant. Okay, so let's look at it. Okay, so as we can see here, we have our point P here, which the point P is the moving point, okay, and A is the fixed point. So if I move P, okay, from A, if I move P, okay, let's look at it. As you can see, the points, the traces of the points in which P lies, or I mean in which P moves, okay, as P moves, all the traces will form what shape? It will form a circle. Okay, it will form a circle. So you need to understand P from A have a fixed distance. Okay, from P to A. Okay, remember A is a fixed point and P is a moving point, and the distance from AP is constant. Okay, is a constant. So when P moves, okay, when P moves around fixed point A, so all the traces for point P will form a circle. Okay, so we can say that from the activity, the shape of locus of point P obtained is a circle with center A. Okay, so locus of point P is a circle with center A and radius R. Okay, so we can see that, oh, this is P. Let me use another color. Okay, so this is P and this is A. So this is the distance. Okay, the R is the distance for A, P. Okay, so as P moves along the point A, so we can say that, oh, all the traces of P will form a circle. Okay, remember before, locus is what? Locus is the path, okay, the path that satisfies a certain condition. So the path is all the points that P is moving. Okay. Okay. So we can say that equation of the locus of moving point P, which the distance from a fixed point A is always constant. Always constant. And it can be used by this formula. Okay. Remember, when we talk about coordinates and the distance, we know that distance, the formula is x2 minus x1 squared plus y2 minus y1 squared. Or we can say that, oh, it's just like the Pythagoras theorem formula. Okay, so that's why PA, we applied this one. Okay, so in this case, okay, the locus, we are talking about the circle. Okay, the locus of point P from point A is the locus. So we are saying that we can use the distance formula in finding PA. So like I said before, R is equals to AP, so we can say PA is equals to R. So let's say our R is 5, example, R is equals to 5, so we can say that, oh, PA is equals to 5. Okay. Okay. Okay, remember, and R must be greater than 0. Okay, next. Okay. So the distance of a moving point from a fixed point is constant and it will form a circle. Okay. This is A, this is B. Okay, next. Okay, the next activity. Okay. So we are going to look to explore the shape and determine the equation of locus of a moving point whose the ratio of the distance from two fixed points is constant. Okay, now it involves ratio. Okay, so let P is a moving point. Okay, P as the moving point. Okay, let me change color here. P, the moving point, such that the distance from two fixed points A and B is in the ratio m to n. So we can say that PA over PB is equals to m over n. And then drag the point on the slider to the left and right so that R changes and observe the circle form. Okay, that's the locus of moving point P from a circle. If yes, can you determine its equidistance? Okay, then drag the slider R to the left again so that its value is 1. So R equals to 1. That is PA to PB is equals to 1 to 1. Make a conjecture about the shape of locus. Okay, let's look at it. Okay, let's dig in. Okay, so we have this one, guys. Okay. Okay, wait a minute. Okay, so if I drag R to the left, so as you can see, the circle will become bigger. Okay, if I drag to the right, it will become smaller. Okay, it will become smaller, but still it will maintain the ratio m to n. Okay, but how about if I drag R equals to 1? What happened? We don't have circle. Okay, again, if I drag R to the left, the locus is circle. But if I drag to the right, the locus is still circle but smaller. But if I drag R equals to 1, the locus is not circle. But actually, what will happen? Okay, what will happen? So when we talk about 1, so the distance between P and A and point A and point B is equal. So when we talk about equal, we are talking about We are talking about midpoint lah. Or we can say that same equidistance lah, not midpoint. It will involve midpoint, but the path is equidistant, no matter where P lies. Okay? Okay. Let me explain in detail. Okay. Okay, so this is what we get when we have ratio m to n. Okay, so from the result, the shape of the locus, okay, shape of the locus is still circle. Okay, it's the circle, which the distance is always which the distance from A to B is always constant in the ratio of m to n. So since we say that PA to PB is equal to m to n, okay, remember ratio can also be formed in fraction. So we can say that, oh, PA over PB is equal to m over n. Okay, remember PA, what does PA means? It means the distance from point A to point B. So that's why we use the formula of distance. Okay, this is distance. Okay, formula distance. Okay, what we need to do is just substitute the value of point A and point B lah. Okay, and then you are supposed to get this form. And this is our locus. Okay, this is our locus, supposedly, when it involves ratio m to n. However, when we have PA to PB equals to 1 to 1, in which the values of m and n is the same, okay, so what will happen? Okay, when PA to PB 1 to 1, so P is always the same distance. P is always the same distance from two fixed points A and B. The shape of the locus is perpendicular bisector line. Okay, like from before, we said that, oh, we have our A here, and this is our B. So this is our midpoint. So P will lies here. This is a moving P. So no matter where P goes, the distance will be the same, right? So this is our locus, perpendicular bisector A, B. Okay, so we can say that, oh, in this case, PA must be equal to PB. Why? Because PA to PB equals to 1 to 1. So we can say that, oh, PA over PB is equals to 1 over 1. Therefore, PA is equals to PB. Okay, simple, right? Okay, let's dig in. Okay, so in these two cases, the ratio of a moving point from two fixed points is constant. Okay, we are talking about two cases. Okay, this is the first case, m to n, and then this is the second case, m equals to n, which is 1. Okay, okay, next, or m equals to n lah. Okay, m equals to n. Okay, next, the distance of a moving point from a fixed point is constant. Okay, let's look at example 1. Find the equation of locus of moving point P so that its distance from point A, 4, -3, is 6 units. Okay, remember, so we have point A, 4, -3. So we have moving point P, which is xy. So the distance is 6. So what type of locus will we have? So of course we will have circle. Okay, we will have a circle. Okay, so when we talk about that, okay, let's look. Okay, that is the illustration. Okay, so this is the illustration. So we have circle in which this is 6 units. So no matter where P lies, the distance from A to P will be 6. Or we can say that, oh, this is R equals to 6. The radius of the circle is 6. Okay, so we can say that, oh, from here AP is actually 6. So when we talk about AP, we are talking about distance from A to P. So we need to know what is the formula for distance. So of course the formula for distance, okay, distance is square root of x2 minus x1 squared plus y2 minus y1 squared. So you just substitute the values because we know that P is xy and A is 4, negative 3, in which A is x1, y1 or x2, y2, depends which one. So just substitute the values. So this is square root. So of course when we have square root, we need to get rid of square root by square both sides. So when we square both sides, we have this one. Okay, and then you expand. Okay, carefully expand it correctly. And then we know that, oh, we have quadratic there. So quadratic, the equation must be equal to 0. So since this is equation of locus usually involves x and y. Okay, so remember, equation of locus must be equals to 0 and in the simplest form. So that's why our equation of locus P is x squared plus y squared minus 8x plus 6y minus 11 equals to 0. Okay, so what I want to say is, when we talk about locus, actually we are talking about distance. Okay, so you need to use distance formula. Okay, so this is it. Okay, let's look at example 2. Point P moves such that its distance from Q, negative to 1, is always 5 units. Again, okay, we have P and Q, and P is moving point. So we have P, okay, we have P here, and then we have Q, negative to 1. So this is the distance. So the distance is always 5. Okay, so what locus we will have? We will have a circle. Okay, that is the locus. Okay, find the equation of the locus of point P. Okay, so basically, if you want to know, the equation for circle is actually x squared plus y squared equals to r squared. This is equation of circle in general. Okay, in general. Okay, so okay, let's move on. So we know that, oh, that means PQ is equals to 5 when we have our points PXY and Q is negative to 1. Okay, so by applying PQ equals to 5, so we are talking about the distance, so it will involve distance formula. So what I do here is I substitute all the informations in the distance formula. Okay, next, of course, the next part, I expand. After expanding the expression, I want to get rid of the square root. So I square both sides here. Okay, squaring both sides, so we will have this part. Okay, again, when we talk about equation of locus must be equals to 0. Okay, so we have x squared plus 4x plus 4 plus 1 minus 2y plus y squared minus 25 equals to 0. And you should remember, equation of locus must be equal to 0 and always in the simplest form. So our final answer is x squared plus y squared plus 4x minus 2y minus 20 equals to 0. So Nak katanya, so this equation is x squared plus y squared plus 4x minus 2y minus 20 equals to 0. Simple, right? Okay. Okay, let's proceed with the ratio of a moving point from two fixed points is constant. Okay, let's look at example 3. Okay, the coordinates of points J and K are negative 1, 3 and 4, 6 respectively. Point Q moves such that QJ to QK is equals to 2, 2, 3. Find the equation of locus of Q. Okay, so first of all, when we talk about ratio, okay, so first of all, what I want you to do is draw a line. So you know that which points, whether J, K and Q, which point is in between both points. So the moving point is Q. Okay, Q is the moving point. So Q is the point that is in between J and K. So let's say we have J here, negative 1, 3. And then we have K here, 4, 6. So Q is in between them. Okay, so it is said that QJ to QK is equal to 2 to 3. Or we can say that QJ over QK is equal to 2 over 3. Okay, so which part, Q will be closer to J or Q will be closer to 3? So what do you think? Of course, Q will be closer to J, because Q to J we have only 2 parts, but Q to K we have 3 parts, which is farther than we have from Q to J. So basically we have like this. So let's say this is Q. Okay, so this is M, our M, which is 2, and then this is our N, which is 3. So actually from J to K we have 5 parts overall. Okay, but from Q to J we have 2 parts, and Q to K we have 3 parts. So that's how you look at the question. Okay, you need to illustrate it. Okay, illustrate it. Okay, correctly. Okay, so how can we find the equation of the locus? Remember before, in the exploration time, we know that when it involves ratio, what type of locus do we have? Yes, we have circle. Okay, we have circle. So okay, from this piece of information, so we can say that, okay, QJ over QK is equal to 2 over 3. That means 3QJ is equal to 2QK. Again, when we talk about QJ and QK, we are talking about the distance from 2 points. Okay, so we know that we are going to deal with distance formula. Okay, so this is the distance formula, and then you just substitute the values. Okay, in this case, J will be x1, y1, and K will be x2, y2. So just substitute. Okay, just substitute the values in the formula. Okay, so we will have this part, and then what are you going to do? Of course, we are going to expand. Okay, expand the expression. Okay, so we have this part. Okay, so when we expand, we have 1 plus 2x plus x squared. We have this second part. Okay, okay, you need to expand it correctly, guys. Okay, remember this second part, please. This second part, please, must be in bracket. Okay, you must put bracket. Okay, so do this part. Okay, put bracket for the second part. Okay, so and then you expand. Of course, we have square root here. So what we are going to do, we need to square both sides. Okay, square both sides. So Remember, 3, you must be squared too. Okay, you must square 3 also. This is why we have this 9. 2 squared, we have this 4. Okay, so the next part, of course, expand and make it equals to 0. Because of what? Because equation of locus must always be equals to 0 and must always be in the simplest form. So from here we have 5x squared plus 5y squared plus 50x minus 6y minus 118 equals to 0. So since this is the simplest form, so this is our equation of locus P. Okay, this is simple, but what I'm afraid is you will make mistake during the expanding process, okay, and during the elimination of square root, especially this type of question 3. Most students, they will tend to forget to square 3 and 2. They just square the square root sign, okay, which is a big mistake. Okay, you should be careful. Okay, let's look at another example. Okay, point R moves such that its distance from point A, 60, is twice its distance from point B. Okay, you see the different type of question. Okay, find the equation of locus R. Okay, again we know that R is the moving point. So R is between A and B. So we draw. So this is A, this is B. So our A is 60 and our B is negative 30. Okay, so the keyword is, okay, point R moves such that its distance from A is twice its distance from B. Distance from A is twice distance from B. So RA is twice RB. So which one is bigger, RA or RB? RA is twice RB. So of course RA will be bigger, right? Because we are talking about RA is 2 times of RB. So R will be closer to A or B? Of course R will be closer to B. So this is where R lies. Okay, so we can say that RA in which M is 2 and N is 1. Okay, teacher, how can we find? How can you simply say that M is equals to 2 and N equals to 1? Of course, from here, RA is equals to RB. So, RA over RB is 2 over 1. In which this is also M to N. So, I can say that, M to N is actually 2 to 1. Correct? Am I right? Of course. Okay, so let's look at it. Okay, RA or AR is the same. Okay, AR is equal to RB. Okay, exactly. Okay, so again, of course, when we talk about AR, we are talking about distance. So equation of locus always deals with distance formula. So just substitute all the information given. Okay, and then you expand. Okay, expand the expression inside the square root. So we will have this part. Remember, the second part will always be in bracket. Okay, will always be in bracket. Okay, better save. Okay, and then of course after we expand, we need to get rid with the square root. So we square both sides. Remember, 2 must be squared also. This is where 4 comes from. Okay, and then expand Again, when we talk about equation of locus must be equals to 0. So we make the right hand side equals to 0. And the other part, equation of locus must be in the simplest form. Okay, you see here, at this part, negative 3x squared minus 3y squared minus 36x equals to 0. So this part is not simplest. Okay, this is not simplest form. So we can see that, oh, all the coefficient can be changed into smaller value by dividing with negative 3, right? By dividing by negative 3. So this is why we have x squared plus y squared plus 12x equals to 0. Why? Because we don't just need to have equation of locus must be equals to 0, but we also need it in its simplest form. So be careful, guys. Must be equals to 0, and also it must be in the simplest form. Okay, see? Simple, right? Oh. Okay. Okay, let's look at example 5. Find the equation of locus moving point P such that its distance from point A, negative 2, 0, and B, 0, 4 are the same. So, we know that P is moving point. So, we have A here. We have B here. So, our A is negative 2, 0. And our B is 0, 4. Okay, so that means P is in the middle. Okay, P moving point but in the middle. So this is P, XY. So when it moves, it will form what? What type of shape? It will form perpendicular bisector. Because of what? Because it is the same. So we can say that, oh, from here, PA is equals to PB. Okay, PA to PB, the ratio is 1 to 1. So we can say, oh, PA is actually P equals to PB. Sorry, PB here. Okay. So it's not circle, the locus is not circle, but the locus will be perpendicular bisector. Okay. When the value of M and N is equal. Okay. Let's look at it. Okay, AP is equal to PB. And then of course use the distance formula. And then expand, and then get rid of square root sign by squaring both sides. Okay, by squaring both sides, and then make it equals to 0. So right here, for x plus 8y minus 12 equals to 0 is not the simplest form. How can we make it the simplest form? By dividing the equations with 4. So the answer is x plus 2y minus 3 equals to 0. Okay, as you can see, this equation, the highest power of x and y is 1. When we talk about highest power of x is 1, we are talking about linear. Or we talk about linear, right? So when we talk about linear, we are talking about straight line. That's why our locus is a straight line, in which the straight line is called perpendicular bisector. Okay, this is a straight line. Okay, I hope you can understand, guys. Okay, let us proceed with solving problems. Okay, example 6. Okay, a goat is tied with a rope to a pole which is planted in the middle of a field, just like the illustration. The length of rope is used is 4 meters. Okay, the length of rope is 4 meters. The goat walks around the pole tied to the end of the taut rope as shown in the diagram. If the coordinates of the pole are A to 4, find the equation of the locus of the goat strap. Okay, as you can see here, okay, we can say that, oh, this is our moving point P. Okay, and we have a fixed point P from A. The distance is 4 meter. Okay, so as the good walks around, the distance from the good to the fixed point will always be 4 meter. Okay, so we can say that, oh, our locus is actually a circle, okay, in which the radius is 4. So what equation of locus are we going to have? Of course, we will have equation of a circle, okay, because our locus is going to form a circle. So we can say that, oh, that means AP is equals to 4. Okay, AP is equals to 4. So first of all, you need to understand the problem. Okay, a good is tied with a rope 4 meters long to the pole. Okay, this is the information given. Okay, and the next step, planning the strategy. Okay, track of the good is a circle with center A to 4 and radius 4 meters. And of course, as I said before, so we know that the radius is 4, or we can say that the distance from A to P is equals to 4. So we know that we are going to use the formula for distance. Okay, formula for distance. Okay, next, implementing the strategy. So since we are talking about, oh, PA is equals to 4, so we are saying that PA equals to 4. So PA is this distance from A to P. So use the formula for distance and then substitute the values of P and A in the formula. Okay, and then of course we need to square both sides because we want to get rid of the square root. So we will have this part, and then you expand, and then after expand, make it equals to 0, because our locus must be equals to 0 in the simplest form. So since it is in simplest form, so we can say that, oh, our equation of locus of moving point P, which is the goat strike around the pole with the rope taut, is x squared plus y squared minus 4x minus 8y plus 4 equals to 0. Okay, so this is simple one, simple one. So this is basically, this is the illustration when we use Cartesian plane. Okay, so we can say that, oh, represent the equation of locus P on the Cartesian plane. It is found that the locus P touches the x-axis at point 2, O. Okay, 0. Okay, 0. Substitute 0 into equation. So when we substitute the equation, left hand side is equals to right hand side. So actually making a conclusion is how you check your answer. Okay, by testing a point on the circle and then substitute it in our equation of locus. Okay, simple. Okay, let's look at example 7. Okay, the diagram on the right shows the locus of a moving point P. Okay, so this is our P that touches the x-axis at a point and is of fixed distance from point A 3, 4. Find the equation of the locus. Okay, remember when we talk about here, okay, let's say this one, this is P, in which the P touches the x-axis. So we can say that, oh, this is AP also, right? So since this is 3 and this is 90 degree, this is 90 degree, because the concept of tangent that touches a line. Okay, so we have 90 degree there. So since the x-coordinate of A is 3, so of course the x-coordinate for P here will be 3 also. Okay, will be 3 also. And only the y-axis will be 0. So what I want to say here is, what is the distance from AP here? Okay, what is the distance from AP here? So we know that since A is 3, 4, so that means the y-coordinate for A is 4. So I can say that, oh, the distance from AP is 4 again. Right. So we can say that, oh, that means AP is equals to 4. So that's how you tackle the problem. Okay, that's how you tackle the problem. So let's look. So we know that, oh, since AP is equals to 4, and we know that A is 3, 4, and P is XY, so substitute these informations in distance formula. So we will have this part. And then, of course, the next thing, whether you get rid of square root sign, or you expand first, it depends. Okay, it depends. And then, of course, this part, of course, we need to square both sides in order for us to get rid the square root sign. So we will have x squared minus 6x plus 9 plus y squared minus 8y plus 16 equals to 16. Okay. So from here, we know that locus must always be equals to 0, must be, and also must be in the simplest form. So the final answer should be x squared plus y squared minus 6x minus 8y equals to 0. Okay, so you see that, oh, this is the equation of a circle. Okay, so this is this equation. Okay, x squared plus y squared minus 6x minus 8y equals to 0. Okay, simple, right? Okay, next. Example 8. In the diagram on the right, A, negative 2, 2, 0, and point B, 1, 0 are two fixed points. Point P moves along the circle such that the ratio PA to PB is 2 to 1. Show that the equation of the circle is x squared plus y squared minus 4x equals to 0. When we talk about show that, you need to prove that your answer, your final answer must be x squared plus y squared minus 4x equals to 0. So you need to prove. Okay, so this is the illustration. Of course, we know that when we deals with a moving point between two fixed points with a ratio, so the locus must be a circle. So this is the locus. Okay, locus P. Okay, that is the locus. So what do we know? We just know that PA to PB is 2 to 1. Of course, we need to use that information. And of course, when we talk about locus, we are going to deal with distance formula. So let's look at our information. So this is our information. So from here, we can cross multiply. So we can say PA is equal to 2PB. So PA is bigger than PB. So as you can see, PA is bigger than PB. Okay, next, of course, we use the formula, distance formula. So substitute the values again. Okay, again, the same process, and then square both sides. Okay, square both sides. Not here. Not here. This part. Square both sides. Okay, square both sides. Okay. So we will have 2 squared 4. Don't you forget that 2 must be squared also. And then expand and make it equals to 0. Since this is not simplest form, okay, this is not simplest form, so we need to divide it by negative 3. Or I should write it divided by negative 3. This part. Okay, so when we divided both sides with negative 3, so we will have our final answer x squared plus y squared minus 4x equals to 0. So our equation of locus will be x squared plus y squared minus 4x equals to 0. Okay, so remember, make sure the value of A is positive. Okay? Okay. Simple, right? Oh. Okay. Example 8, B. Show that point C22 is on the circle. Point C22 is on the circle. So how can we know that point C22 is on the circle? How? Okay, we know that our equation of locus, our equation of locus before is x squared plus y squared minus 4x equals to 0. Okay, so how can we prove that point C is on the circle? Okay, how? So, of course, by substituting the coordinate C in the equation of locus. Okay, so let's see. When we substitute the values of point C in the locus, so we will see that, at the end, we will have 0 equals to 0, in which we will say that, left hand side is equals to right hand side. The same value. Okay, since left hand side equals to right hand side, in which 0 equals to 0, thus we can state that coordinate C22 is on the circle. As simple as that. Okay, I hope you can understand, guys. Okay, so evaluation time. So I want you to try these two questions and remember to discuss the answers with your teacher. Okay, so of course homework. Okay, homework for today's lesson. Okay, and remember, guys, before I end up, remember when we talk about equation of locus, okay, first we deals with circle. Okay, we deals with circle. AP is equals to R. So equation of circle. This is one. The second one, when it involves ratio. Okay, so 1 AP over PB is equals to M to N. So this is circle. But when we talk about the other one, when AP equals to PB, so this is straight line, or we will say that perpendicular bisector. Okay, another part, of course, equation of locus must be equal to 0 and it must be in the simplest form. Okay, and we are talking about equation of locus. So equation of locus deals with distance formula. Okay, so these are the important points of equation of locus. So I hope you will remember this. Okay, you will remember this. Okay, so before I end up my session, guys, success is the sum of small efforts repeated day in and day out. So from me, good luck and all the best. I end up my session with Assalamualaikum warahmatullahi wabarakatuh and peace be upon you.